All right. So, good evening, everyone. So, my name is Ayobami Salau. So, you're welcome to this webinar titled End to End Machine Learning from Idea to Real World Impact. So, we are having our guest speaker here with us today. His name is Sattar Sharafa. So, Sattar Sharafa is an LLM engineer, an AWS solutions architect, and also a back-end engineer at Autorite. So, and he's going to be taking us through how we can build an end-to-end machine learning project from just your idea and into how we can transform the idea into what will really impact the real world. So, and I want us to pay attention so we can have a very, very experiential webinar this evening. So I'm going to call on Sata so he can start. So can we just please welcome Sata? So Sata, you have the floor, please. Welcome aboard.
Hello, good evening, everyone. I hope we all are doing well. So, my name is Sata Osafa. Like engineer Bami have said, I'm an LLM engineer and also an AWS solutions architect at Autorite Integrated. So, basically, we are going to our topic for today is end-to-end machine learning from idea to real world impact. So I welcome everyone. So today we are going to demystify machine learning by thinking about it in different aspects. Machine learning isn't just about having your data or your recipe. It's about having the right ingredients in the perspective of cooking. I'm pretty sure we all are familiar with cooking, but I don't want this to look more of like something that um I'm going to like be introducing to you all, and you will not really have any idea of what machine learning is. So I'm going to be using different scenarios and different analogy as I proceed. So like I said earlier, it's just about having a recipe. It's not just about having a recipe, it's about having the right ingredients, cooking them well, and serving the dish to the right people at the right time. So what we are going to be learning today, we are going to be learning the full machine learning life cycle, from data to deployment, roles that bring ML project to life, how business problems are translated into ML solutions. That is how you can use machine learning solutions to solve some basic business problems. What makes a model production ready? Like what will give you the assurance for you to like deploy the model to external users to start using, how real companies deploy machine learning models, challenges you face, real world Afghan use cases, and the non-technical career paths in AI and machine learning. That is like if you feel machine learning is an outrageous field for you to like start with, you can start with the non-technical career paths. And basically, can you move to the next slide, please? So, the big picture, the machine learning life cycle. So, I evaluated this into multiple stages. So there are 6 stages. So, the problem definition stage. So, this has to do with you getting to understand the kind of problem you are trying to use machine learning to solve. And we also have the data collection and cleaning stage, whereby you have to prepare your data, you annotate it, you clean it. And you also have the model training stage. This is where the real work begins, whereby you have to like train a custom AI model for the stuff to like be able to like process for the stuff to be able to like give you the output you've required from the model. We have the evaluation stage whereby you have to like test it with some custom data sets for like evaluation to see if the model really does what it's intended to do. We also have the deployment stage whereby you have to like deploy it on a server for external users to use. We have the monitoring and maintenance phase. So this is one of like the crucial phases. The deployment phase and the monitoring and maintenance phases are like one of the crucial phases because without these two phases, your machine learning model it's nowhere to be found. There is an analogy here whereby I said like farming, you decide what to grow, you plant seeds, you prepare your crops, harvest, you sell, and also maintain your farm. This is like a basic simple analogy. The stage one. So Stage one, from business problem to machine learning problem. Every great machine learning project starts with being a detective. You need to start with a real business challenge, not a solution looking for a problem. So we have countless people building solutions that at the end of the day, you start looking for the problem that the solution will solve. It's somehow, so it doesn't have to be like that. It has to be the other way around, whereby we get to understand the problem we're trying to solve and we ask ourselves, can we use machine learning to solve this problem? And if yes, we start building machine learning models. So an example, like I said, a fraud detection in banking. So the business problem we get to from this analogy, we get to understand that there is like a business problem whereby the bank is losing money to fraudulent transactions, and we ask ourselves, can we solve this stuff with machine learning? And yeah, when we felt okay, yeah, we can solve this stuff with machine learning. Like, can we predict if a transaction is fraudulent based on the transaction pattern, user behavior, and timing? Like, for instance, now a fraudulent transaction can like come in a very, very huge amount, like probably maybe like 150 million naira. The bank actually receives.
So sorry about that. I think our speaker's network is somehow fluctuating. So we're going to wait a moment for him to. Do.
Oh, can you hear me now?
Yes, loud and clear, please.
Yeah, I'm really sorry about that. My mic was on mute. So let me just try to go back to where I was. So stage one, like I said earlier, from business problem to machine learning problem. So like I don't know if I don't know when my mic went off, but I'm going to like start this again. So like I said earlier, every great machine learning project starts with being a detective. You can't just jump into like building your machine learning project directly. You have to get to understand the problem you're trying to solve. You ask yourself, can I solve this problem with machine learning algorithms? What are the things I see? What are the criteria I was able to like pull out and feel like, okay, I have these things. Can these things fit in? Can these things fit into a machine learning? Can these things fit in a machine learning algorithm? Like, is it possible for a machine learning algorithm to work with this kind of a use case? So I made an example, like an analogy, yeah, whereby I said fraud detection in banking. We have countless banks that are facing fraudulent activities. So we get to understand the business problem that the company are losing lots of money due to fraudulent transactions, and they felt, oh, these fraudulent transactions, how can we like mitigate these issues? So they were like, okay, oh, let's try to see this from the machine learning aspect, that can they predict if a business is fraudulent based on transaction patterns, user behavior, and timing. Obviously, fraudulent activities have to do with huge sum of money entering a user's account. They can check if the user just created the account. They can also check if the timing whereby the money entered the account and the money wants to like go out of the account. They can also check that. So this is where the detective work come comes in. So before you start building machine learning project, you need to like um act more of like you need to like act like a detective in most cases, because you can't just like take in any data you just like come across and just like push it in and just expect the machine learning algorithm to just give you what you need. Like garbage in garbage out, it's actually very very bad. Like most of the models I've actually worked with, I like cleaning my data, annotating it, and doing things like that, like all sort of data analysis trend things. So my okay, next slide. So we also have the data collection and cleaning. Just like I said, annotating of data, you're trying to filter out the bad data and the good data. So we have multiple sources like database, sensors, APIs, and manual entry. So I feel we all understand what databases are, where data are being stored. Probably maybe like you sign up on a website, your data is going to like the database directly. We also have sensors, like this has to do with Internet of Things devices like Alexa, for instance, Amazon Alexa, people using Alexa at their houses. Alexa sends anonymous data to like Amazon secretly. We also have APIs. APIs are like APIs. They are called application programming interfaces. These are like connectors or like bridges between the client and the servers. So I'm only saying something that there is this 80% reality that people don't like tell you most in AI scenarios, that data cleaning is 80% of the work. Think of it like cooking. So if you think of it like cooking, we have multiple data sources. Like I've said earlier, we have databases. This is like your mini mart whereby you want to like get your ingredient, or your supermarket or your market. You also have sensors. Sensors can act as fresh ingredients. We have APIs, so ordering from suppliers, and we also have manual entries. This has to do with people that are like growing their ingredients in their house. Like for instance, now I grow this thing, I grow some leaves at my backyard. Like I have like a small garden. So the cleaning challenge has to do with you trying to like you're trying to like clean your data. Like for instance, now you can't use a dirty plate to eat. You understand? If you want to eat, you need a clean plate. You've used a plate before, you have to like clean it in order for the stuff to like look more presentable to you. So now we have like cleaning the missing values. uh, Most times when you get data from their sources, like for instance, databases now, we have null values in our databases, or probably maybe like undefined. I don't know if we have any programmers among us. So undefined has to do with a variable that has like been instantiated and it doesn't really have any value. And so these missing values, we need to like populate them in order for the model to like see them as a data to like work with. We also have duplicate data. We need to remove duplicates as much as possible, because duplicates, they contribute a lot to the model like anytime you're trying to like do the model evaluation, you notice that, oh, this model is behaving somehow and things like that. We also have noise. Noise has to do with probably maybe like spoiled or contaminated data. whereby we have like our databases. The database is meant to like store. We have multiple tables. Like a particular table is meant to store data for only a particular user, and we also have another table that is meant to store data for maybe like the comment in a website. We can't merge those two tables together. It will lead to noise. Like the user table is only meant to store user information, not the comment information of the user on other posts. So we also have inconsistencies. So inconsistencies have to do with measurement in different units. When we are talking about measurement in different units, probably maybe like in your database you're trying to like store let me say maybe like you're trying to store age, and you're storing age in like a string format and things like that. And you know, storing age as string is not as inconsistent as storing age as number, because age is a number. So I'm only saying this, there is always a pro tip: garbage in, garbage out. If you should like put in garbage, you are definitely going to like get garbage. So spoiled ingredients go in the dish. If you are trying to cook and you are using spoiled ingredients, it's definitely going in the dish. This applies to machine learning models too. If you should like take if you should like take your data, you try to clean it, refine it and things like that, you definitely get a positive output. So we now have stage three. This is like the major part of machine learning, whereby you have to like train your model. You choose the algorithm you want to like use to like train your model. We have neural network, decision tree, transformer architecture and things like that. So you can think of the model training as you trying to like teach your child how to do something. So teaching a child, so like model training is like teaching a child through examples, corrections, and practices. Like you're trying to teach your child how to walk. You will not just like sit down one place and just feel like, oh, it will work one day, it will work one day. It doesn't work that way. You have to start by teaching it. You have to start by like starting to like get your child familiar with like a crawler, like this children worker and things like that. From there they will get to understand how firm their legs are on the ground and things like that. So no and Prof, can you go back? I'm not really done. So so there are some key steps to model training. So like I said earlier, choosing the right algorithm. You need to be able to like choose the right algorithm before you like start training your model. You split your data, you train by data and test your data. You also tune hyperparameters. This has to do with um like iterative process of model training. After like training your model and you just notice, oh, some parameters need to be tuned, you need to like tune those parameters. An example of tuning a parameter has to do with probably maybe like you just fetch some tons of data from a database, and those data you need to like change some parameters, like from string to probably maybe like integer. So an integer is a number. So and we also have the iteration process and improve. You have to like iterate, keep iterating, keep trying to like improve your model in order to like get a very very perfect model. So like I said earlier, like teaching a child, you have to like keep giving it examples, corrections and practice and things like that. Next slide please. So we have the model evaluation stage. So this model evaluation stage is actually beyond accuracy. Here's a crucial point you all need to know. Accuracy alone is not enough. Uh, so it's like a student who memorizes test answers but fails in real life. You want to do exam, you start memorizing things, like you start memorizing question and answers. You enter the exam, you pass. But when a situation comes up whereby you need to like make use of that your knowledge to like you want to like apply that knowledge to real life scenarios and things like that, you find out that you have really failed, like that stuff has really failed you. So we also have some key metrics. Hello, can anyone hear me? Hello.
Can hear you loud and clear.
Okay, we also have some like key metrics to like keep in our mind. So we have like precision. When you predict something, how often are you right? Like you need to take note of that. That anytime you try to like build your model, you need to be able to like understand that if your model try to predict if an image contains a mango leaf, it should predict that image, and it should return an output to you that that image contains a mango leaf. So we also have some real world testing scenarios whereby you need to like test your model in scenarios that can mirror actual use, like scenarios that can mirror real world use cases. So now, and there is also something we call overfitting, when your model performs great in testing but poorly in reality. So people don't really people there is one mistake people do there is one mistake people do while trying to like evaluate their model. So they tend to place the they tend to place the they tend to place the way the model performs while testing over the way the model will like perform in reality. Like they just go straight up to deployment. They don't think of production practices and things like that. And at the end of the day, the model will like fail them and things like that. So next slide, please. So we also have the stage five. This has to do with deployment. So I could so like 2 weeks ago, I actually deployed a model on there is this service called SageMaker on AWS. So AWS is Amazon Web Service. It's like the leading service on infrastructure as a service. So when we're talking about infrastructure as a service, we are talking about people that like provide infrastructure as a service. Anytime you hear cloud, people what comes to your mind is oh Google Cloud, iCloud, and things like that. The cloud is actually beyond that. The cloud has to do with infrastructures like AWS. Like I said, it's an infrastructure as a service. They buy they have their own data centers and things like that, and you host it on their data center from the comfort of your zone. You can just like open your phone, deploy a model, and like they will do it physically on their end. So AWS, like I said, it's an infrastructure as a service. So I deployed a model on there is this service in AWS called SageMaker. So SageMaker is actually used to like build models, train and deploy. So I use SageMaker. So part of like I said, I'm going to also use an analogy in this situation from kitchen to restaurant menu. This is where the rubber meets the road. Like for instance, now you are trying to like learn how to drive and things like that. You are driving in your compound, like you have a very very large compound. But have you actually thought of the moments whereby you go to like a high traffic code to like test your driving skills? So deployment methods, like they are very very crucial. You need to understand how to like deploy your models the best way possible. So we have multiple deployment methods. We have APIs, like I said earlier, application programming interfaces, like a drive-through window. This is like the communication protocol between your client and the server. So you as a client, you need a way in order to like interact with your model remotely. So what you're going to use API. So you can use like a REST API or WebSocket, anything you want to use. You need a way in order to like communicate with your models directly. We also have mobile apps. So there are multiple packages. I'm not going to like go deep, but I'm just trying to like make you all understand how models can be deployed. So there is this package called TensorFlow JS. So TensorFlow is actually another framework for training models. So anytime you just train your model, you are going to like get your model in the TensorFlow file format. So you can think of this stuff as probably maybe like when you try to snap, for instance, now on my phone now, if I try to like scan a QR code, I can just launch my camera. I'll just place it in front of the QR code, and it will detect that this stuff is a QR code. So there is a machine learning algorithm running on the mobile app on your phone, like the camera application. There is a machine learning model running inside the camera application for you to be able to like detect So it's a vision model for you to be able to detect that, oh, this person is actually trying to like scan a QR code. Okay, this person is not trying to like snap selfies or portrait photos and things like that. And so I'm okay, I'm also going to like use a restaurant as an analogy. You can make the world best dish at home, but until you can serve it consistently to hundreds of customers daily, it's not a business. You understand? So you're trying to like work on your comfort zone, trying to train your model on your computer. It's not prod ready, it's not production ready until you try to use that same approach on millions of users and try to get feedback from them. It is until like tons of them, like probably maybe like 90% of them start telling you that, oh, this model you deployed, yeah, it's working perfectly. That's when you now know, yeah, your model has start performing the way it should. It is not like you're trying to test locally in a system. That's when you now feel like, oh, yeah, my model is pod ready, let me just deploy. It will fail. It might fail, but tons of time, the stuff will definitely fail. Next slide, please. Okay, so we also have the monitoring and maintenance stage. So the monitoring and maintenance stage has to do with you trying to like monitor your model after deployment. So immediately you deploy your model. So this particular stage has to do with like there are countless ways whereby you can monitor your model, but this particular stage is actually where most machine learning experts or machine learning engineers fail, whereby you just deploy a model and they don't really monitor it or they don't maintain it. Because we understand that everything is evolving, technology is evolving and things like that. We need a model that would like also evolve to to what we are trying to do. So we need to like always monitor the models, maintain it. So the way technology is evolving, we are getting new data day by day. What works last year might not work this year. So imagine you deploying a model that like detects if a car is an electric car or an hybrid car, and you deploy the model. Let me say probably maybe like 10 years ago. So I don't think we've already had electric cars then. But now we already have electric car. But if they not maintain that model, it will never detect if a car is electric now. Like a oh sorry. Okay, let me just use another analogy. Try think of something that you think of an analogy of you trying to like deploy a model like 10 years ago. We have normal cars, no electric cars. So that model is if this car is let me say if this particular car does something like this or doesn't do something like this. For instance, now the model is there to like predict. ah, I don't to like put this in a better way. But like if you should deploy a model and the model predicts something, and over the years, like let me say probably maybe like after 5 to like 10 years, if you not maintain the model, it will perform woefully. It will not behave the way it's like meant to like behave. So you need to like always monitor your model. Like me, for instance, now I have a model that predicts cancer lesions. So it predicts skin lesions. So most of those skin lesions, like you can think of a skin lesion as more of like a mole or something that is like on your skin. I don't get to like understand what that is. So that model, you just snap your skin, you send it to the model, and it will tell you if the image is cancerous or not. So that's an example of a model. So if I don't keep training the model with existing data of human skin lesions, it will not perform. It will not keep performing as performant as it it was performing. I don't know if you all like understand what I'm actually trying to say, but you just need to just like keep monitoring and maintaining your model. If new data comes in, you need to like treat that data, clean it, annotate it, use it to like feed it to your model. Like use it to like retrain your model. So model training has to do with an iterative process. Next slide, please. So we also have roles in machine learning projects. So we have data scientists. So like these people design the model. So we have machine learning engineer. So these people build pipelines, DevOps. These people are into deploying and scaling. We have business analysts. So these people are the people that like think of them as like the studio executive of a filmmaking industry. So they get to like they get to they get to like make everybody understand that this model that they're trying to build aligns with business goals. We also have the product manager, the creative director. Next slide, please. So, what makes a model production ready? So, beyond it works on my laptop, like I said this earlier, don't just think that this model works on my laptop. Let me just deploy it. No, you need to be able to like understand that moving from a working model to production is like the difference between cooking for your family and like trying to like open a restaurant. So, I'm going to like be mentioning the production requirements. So first of all, the speed and scalability, can it undo thousands of requests per second? So there is something we call auto scaling group on AWS. So this has to do with if you this has to do with you deploying your model, and if millions of people are trying to access the model at the same time, it will do an horizontal scaling. So horizontal scaling has to do with it trying to like launch like countless servers, like let me say maybe like 10 servers more plus the one you're actually using, like it will launch 10 servers more plus the one that you actually deploy. That's like 11 servers. So those 11 servers will like be able to like handle tens of millions of users at the same time. You also have security and compliance, so you need to be able to like produce guardrails among your models from security vulnerabilities like prompt injection. So prompt injection has to do with um, people trying to like query a model in order to like get information that model should not like reveal to external users. We also have explainability. This has to do with you trying to like explain why it made the decision. Why did your model make this decision? You should be able to understand why your model made this decision because you are the one that built this model. We also have monitoring and retraining plans. How do you keep it healthy long term? Next slide, please. So we have common challenges and how to like avoid them in machine learning projects. So many machine learning projects are like building a bridge that doesn't reach the other side. So you need to like understand these common challenges. You have bad or insufficient data. So if you have bad or insufficient data, trust me, this is garbage in, garbage out. Anything you give your model, you will also get the results. We have misalignments with business needs. Imagine you trying to like build a model that doesn't like align with any business need or anything. It's like you trying to like build a solution and looking for a problem. Like I mentioned earlier, we have unrealistic expectation. You are expecting magic to happen instead of engineering. You change this model. You should like be expecting this model to like come out the same way you expected. You have like model failure in real world. So this model failure in real world has to do with models that have been deployed in production. Like I said earlier, you have to be able to like understand the production best practices before trying to deploy a model. We have lack of stakeholder buying. This one has to do with misalignment with business need. You need to like understand what business needs. So so we have some prevention strategies. You need to start with a business problem, understand the problem, not the technology. Set realistic expectations early. So you need to understand that okay, this model I'm trying to build, this is what if I should give it this kind of input, it should come out with this kind of output. You need to like plan for production. You need to like understand that okay, this model I'm trying to build, if I build this finish, if I try to deploy, how will I deploy it? And also invest heavily in data quality. Like cleaning your data has to do with 80% of the work. You understand what I'm trying to say? So if you should clean your data, like if you should like clean your data, like clean it very well, you are going to get a very very nice output. Next slide, please. So we have new word ML in Africa. Like Africa isn't just adopting AI, it's innovating with it. So some of the key applications that machine learning applies to is fintech, fraud detection, and credit scoring, health, disease prediction, medical imaging. So people don't have to like go through the stress of waiting for like 2 weeks in order to like understand what kind of tumor or something that what kind of tumor that has to do with what kind of tumor is in the image that is in the x-ray that they took of a particular patient. We have education. We all are using ChatGPT. So ChatGPT is a machine learning algorithm, an LLM to be precise. So they actually trained it with tons of data. We have agriculture, crop disease detection, and yield prediction. So people use machine learning algorithm to detect if crops are going to like die or not. Next slide, please. So we also have the non-technical career path. So beyond coding, you don't need to like code to work in AI or machine learning. So there are career options. You have product management. You can like be managing the whole machine learning process. Like you can be the one getting to like you can be the one making sure that you can be the one getting to like make sure that every machine learning engineers or everybody working on a particular sub module of trying to like build the machine learning algorithm. We have strategy and operations. You guys you can choose to like handle how to like scale and grow. We have quality assurance, making sure everything works, QA. We have data annotation and labeling, teaching AI what to recognize. You can like label like hundreds of data with potato. So the model will get to understand that okay, this model is these images we are trying to like train the model with. It's containing potato images. We have business analysis and analytics. This has to do with translating between business and tech. So these people are like the bridge, like the API between the people building the model and the businesses, like the end users that are actually requesting to use machine learning to solve a particular problem. Next slide, please. So we also have the future of AI and machine learning. So AI is everywhere. We are moving toward a world whereby AI is like electricity. It's invisible but essential. So there are some key trends. AI AI becomes infrastructure like electricity. You will use it without thinking about it. We have some AI ethics and governance, rules and regulations that will shape how we build and deploy AI. We also have some hybrid skills in demand. So people will combine AI knowledge with domain expertise. So what this means for you is the question isn't whether AI will impact your field, it's how you will shape the impact. So early adopters who understand both the possibilities and limitations will lead the transformation. Um, Next slide, please. So I'm going to like be providing some key takeaways. So I'm dividing them into four pillars. So these are things I always keep in mind. So machine learning is a team effort. I don't think I can. I don't think I'm actually the only one that can like build and like scale machine learning algorithms. Like for instance, now it is not only one person that's handling ChatGPT or Claude. There are like multiple departments and things like that. So they're all working together in order to make sure this this machine learning large language model acts the way it's actually supposed to act. So it's a team effort. So that means success requires diverse skills working together. So multiple people trying to like work together is like the best approach while trying to like work in a machine learning niche. Also data quality is king. Like I said earlier, cleaning your data is like 80% of the work. If you not clean your data, it's like you trying to like train your model with garbage data. And if you train your model with garbage data, you definitely get garbage results. We also have deployment and monitoring matter. So you should like be able to like monitor your model how it performs. So there is something we call evals. So evals has to do with AI agents, but it's more of like a general term whereby you run tests on your models, and the output you weigh the output to get to understand how your model think in real time. You can work in AI without coding. Their domain expertise plus AI literacy, everything is very, very powerful. So you can actually work in AI without coding. Like for instance, now, like I said, I mentioned um some niche. I mentioned some niche. Like you can actually be a product manager under under machine learning niche and things like that. But you understand how things like this like work. You don't have to like be a programmer in order to like fit into all this niche. You can be a data annotator or data labeling specialist and things like that. Yeah, okay, next slide. Okay, so I'm actually going to like be giving some next step in order for you to like take if you want to like be a very very successful person in the AI field. So you need to like always keep in mind that before you start building any machine learning algorithm or machine learning project or like any machine learning model, you need to like always identify the problem you're trying to like build, because machine learning models they're actually worth it, but it's not worth it when you start like building without trying to like solve a solution. So you need to identify your problems in a particular field that you're trying to like actually work with. So that the AI can like be able to like solve that particular problem. You ask yourself, can I use machine learning to like solve this stuff? Can I use machine learning algorithms to like solve this stuff? Like I made an example that I actually built a churn model. So churn has to do with companies getting to understand if their users will stop using their service or not. And they are going to like actually feed the model with tons of data, like hundreds of data. And the model will just return, okay, this user churn, this user will not churn, this user will stop using your service, this user will not stop using your service. So you need to like get to understand things like that. Also, you need to like learn about data, how to collect, clean, and understand data. You need to like understand how data works. Don't don't label a data as a string when the data needs to be an integer. It will affect your model performance. It will definitely affect your model performance. You join AI communities like Mindflux Academy. So they have their own AI community and things like that. You can join it. And also you need to consider how AI could augment, not replace what you already do well. I use AI every day. I use AI to learn. So I use AI to like impact in what I already know. So I don't think AI can replace me, but I feel I can be a better version of myself trying to use machine learning algorithms, AI or LLMs in general. So so I think that's all for my end. I think that's all for my end. So any questions? Any questions?
Uh, Okay, so thank you so much, Engineer Sharafa. So thank you for that insightful session. So we are going to be asking questions now. We are going to be taking questions basically from those that join the webinar. So though we have one question from Mosun. So she asked a question. Okay, I think I will ask our first question. So she said, just wondering, for someone with little or no knowledge of machine learning, can you broadly explain what you mean by split data, like train, validate, and test? So perhaps using a hypothetical example.
Okay.
So,
Okay. Thanks for that question. That's a really beautiful question. Okay. So basically, what I actually mean by splitting data, training, validating, and testing. So validating. Okay. Let me actually start by splitting data. Splitting data has to do with like if you want to like train a model, you need to, let's say probably maybe like you have like 10,000 images and you're trying to like train a model, you need to be able to split it into two places. So you need to be able to like split it into the data that would like be used to like train the model and the data that would like be used to evaluate the model. Why do we do this? We do this because we want to like want to make sure that the kind of data we are trying to like use to train the model is going to be the kind of data that we're going to like try to use to evaluate the model. So evaluation has to do with you trying to like test it, trying to run automated tests against models and things like that. So concerning um training. So training has to do with you taking the training part of the data to like build a model, and validation has to do with you trying to evaluate. You understand? So testing now have to do with you trying to input your own test or trying to like invite someone from an external source to like test your machine learning model with their own personal data in order to know if it fits into production. And uh, I also saw another question: when a model fails in real world, are there any practical solutions? Yeah, there are countless practical solutions. So, first of all, what most people actually do, but I'm going to like be talking from my own perspective now. What I actually do now is when I actually deploy a model, there is like a follower model to like take over. There is like a follower model to like take over. There is like a follower model to like take over anything I'm trying to do. If a model fails, every request that is coming to that model goes to that follower. And anytime a model fails, what people actually see as a model trying to fail is you're trying to like asking it a question, you like asking it a question, and it's not giving it the necessary output. That issue is actually coming from your end because the kind of data is like used to like change the model. It's not like it's not good enough. You understand? You need to like be able to like validate your data and clean it. And there is also another part whereby it has to do with your model. Your model is actually a performance one, but if um countless users, like let me say maybe like hundreds of users try to access your model at the same time, the stuff can actually crash the server and the stuff will be returning like there are multiple different kind of error. So there is like a 500 error. So that 500 error has to do with internal server error. And if that should crash, just know that yes, the issue is coming from your end because it has to do with it has to do with the way you like deploy the model on production. So that was the main reason why I mentioned ASG earlier on when we're trying to like do this lecture. I said something about auto scaling group on AWS. When you deploy your model on AWS, there is this auto scaling group whereby if countless users try to access your model at the same time and the server crashes, that means probably maybe like you're not using the scaling group. So the scaling group does like a horizontal scaling. This horizontal scaling has to do with spawning countless amount of servers. Like if you have 100 of users and one server can only handle 20 users, it is spawn 4 extra servers added to that server so the stuff can like handle the load. I also saw an extra question for one seeking to become a data scientist. What steps or advice would I advise you? And communities and platforms can join. Thanks a lot for the session. Very insightful. Okay, thanks for that, Nelson. I really appreciate. So, if you are seeking to become a data scientist, so one thing I would like recommend for you is to like first of all register with register with an accredited academy whereby they teach data science and data analytics in general. So you can actually register with Mindflux Academy. And also the communities and platforms. So I spend most of my time on Reddit. I don't know if you know Reddit and LinkedIn. So Reddit is like a community platform, just like Stack Overflow. So you meet countless numbers of people with a variety of skills. So the Reddit has countless number of AI and machine learning communities like Open AI, community that has to do with RAG. So RAG is retrieval augmented generation. So this has to do with a model trying to like access answers from multiple sources. Like I can create RAG for Wikipedia and I'll do it in such a way that my model will be accessing updated data from Wikipedia. So you can access community, you can open Reddit, you can LinkedIn. I most times I actually follow people that are like I actually follow people that are like into machine learning and all sorts of things like that. So I think that's all for my end. I think that's all for my end. Prof.
Okay, all right. So thank you for that insightful session. So really appreciate you so much, and I hope all the learners that joined us have been able to pick one or two informations that can actually help them boost their career in data science, AI and machine learning and even data analytics. So just to wrap it up, so we're going to talk about our pricing for our program here at Mindflux Academy. So we have a discount actually going on at the moment. So you can see our actual price is actually stated here, but we are running a 100,000 discount where you get a 100,000 discount free. So that means that you can actually now pay 150,000 instead of 250,000. So you can pay 150,000 for our course. So and also you can actually contact us on this number that we have here and this email, and you can visit our website. And also, just to add to it, we are going to be having our boot camp on the 25th and 26th of this month. So we just want to, walk you through how you can build real world projects in, cyber security, AI and ML, and data science and analytics. And you are going to actually get a certificate of participation. So you can join us virtually or physically. But for the physical one, so the slot is limited. So, but you can join us virtually. And I'm going to actually copy the link, paste it in the chat section so you can actually, join to register for our webinar, basically, so that you can join us. So I pasted it in the chat section. So you can actually go to our website and you can get more information about us and get to know, and you can actually join our WhatsApp community to get updates timely about our courses and about our webinars and boot camp. So we want to use this medium to actually thank you for attending our webinar, and we want to give a shout out to um, Sharafa Sata. So he really did justice to actually how to end-to-end machine learning from idea to real world impact. So thank you so much. So really thank you for that session. So and we want to see you at our bootcamp and we want to see you register with us. So thank you everyone for joining us. So we're going to be calling it a day for this webinar. So please, you can look out or watch out for another webinar that we're going to be having anytime soon now. So we have our webinars on cyber security, AI and ML, data science and data analysis, and so on and so forth. So you can actually look out, keep checking on our Instagram page. You can check us on our Twitter page, and also you can check us out on our actual website. So thank you so much for joining us. So see you some other time. Bye bye.